Hello and welcome to my channel. I am Mensa Ogesin. Thanks to Reverend Calvin Samodonko and Ebenezer Bafo Ewa for supporting my channel. You can also support my channel by donating through my mobile money number +2330245360793. Please, I want to buy a microphone and a camera to produce quality videos. So you can donate through this mobile money number. My name is Mensa Ogesin. Now, I was looking for 1,200 Ghana cedis, which is equivalent to $211, but I've got 240 Ghana cedis, so it has left with 960 Ghana cedis, which is equivalent to $169. So your $1, your $2, your $3, your $5, or any amount that you can donate is highly appreciated. Your 1 Ghana cedi, your 2 Ghana cedis, 3 Ghana cedis, 10 Ghana cedis, 20 Ghana cedis, or any amount that you can donate will be highly appreciated. I love you and I hope you donate. Thank you for donating. Now let's go to today's lesson. Today we are going to look at how to differentiate trigonometric functions using the quotient, the product, and the chain rule, or the function of a function, or the composite function rule. Here we will look at the tricks involved in differentiating the trigonometric identities, or the trigonometric functions rather. Now let's take the first example. If I take y equal to x squared sine x times cotangent x. Here, should I use the product with the chain rule or the function of a function, or the quotient rule? What do we do? This is what we're going to do. Here we can simplify this one. So we have y equal to x squared sine x times cosine x divided by sine x. And quickly, you cancel this out. Very simple. So now you have y equal to x squared cosine x. Very simple as that. Now let's do the product. We take u equal to x squared, v equal to cosine x. The derivative of u with respect to x will be 2x. The derivative of v with respect to x will be minus sine x. So we have derivative of y with respect to x equal to v. And what is v? Cosine x times 2x plus u. X squared times minus sine x. Here don't multiply 2x by the x. This x is an angle. So the 2x will multiply the coefficient here. So we have 2x cosine x minus x squared. U is x squared sine x. And we are done. If we simplify x out, we have x into bracket. Sorry, if we factorize x out, we have x into bracket 2x cosine x minus x sine x. And that is that. Now let's take the next example. Watch as I give you the tricks. Now the second example is we have y equal to sine x cosine x. Wow. So if we take sine x cosine x, no simplification. Let's do the product rule straight away. You have u equal to sine x, v equal to cosine x. This will give us a very nice result that you've not thought of. Let's wait and see. Here, the u on dx will be cosine x. The v on dx will be negative sine x. Now, the derivative of y with respect to x will be v, that is cosine x times du dx, the same cosine x, plus u, sine x times dv dx, negative sine x. And this will produce cosine squared x minus sine squared x. If you have not watched my video on double angle formula, check the description for that video. This will straight produce cosine 2x as the derivative of y with respect to x. Because we said that if you have cosine of a plus a, it is the same as cosine a minus sine a, and that will give us cosine squared a minus sine squared a equal to cosine 2a. That is a plus a. Wow. Now let's move on to the next question. Now, if you have questions, leave them at the comment section. Or if you have any topic that you want me to treat, leave it at the comment section. Or you can send it through my WhatsApp number, which is also my mobile money number. Then it will help me to also do what we want for you. That is that. Now let's move on. Now this is the third question. Here we have y equal to secant x times cosecant x. Wow. So here, what do we do? If we change this will become 1 divided by cosine x times this will become 1 divided by sine x, and it will be 1 divided by cosine x on sine x. Very simple as that. So what do we do? Should we change it? And this one will become cosine x sine x all to the power -1. Okay. So here what do we do? Remember that we said that if you have sine x plus x is the same as sine x cosine x plus cosine x sine x, which is equal to 2 sine x cosine x. Very simple as that. And here this is the same as sine 2x. So if I divide it by 2 and divide it by 2, I'm going to have half of sine 2x is equal to sine x cosine x. So in place of cosine x and x, I can put inside half of sine 2x. So let's do that here. We are going to have y is equal to half of sine 2x to the power -1. And here we have y equal to 1 on 2 to the power -1, then sine 2x to the power -1. And here we have y equal to 2 sine 2x to the power -1. Wow. I want to revolve all secret to you, that's why I'm doing this. So here, this is the constant. So you just differentiate this using the chain rule. That's the function of the function rule or the composite function rule. So here we will let u to be equal to sine 2x. Wow. This implies that y equal to 2u to the power -1. So here, this is also a function of a function, but we differentiate it very simple. So du on dx will give us, we differentiate what is here, that is 2, times, we differentiate the whole function. So we differentiate sine, we get cosine 2x. So this will give us 2 cosine 2x. And here, dy on du will give us -2u to the power -2. Sorry? Yeah, -2 is there. So this will give us -2. And what is u? U is sine 2x to the power -2. Wow. So here the derivative of y with respect to x will be giving us 2 cosine 2x dot minus 2 sine, what is there? 2x to the power negative 2. So we are going to get this as 2 cosine 2x times negative 2 divided by sine 2x all squared. Wow. And this is the same as minus 4 cosine 2x divided by sine 2x times sine 2x. And what will this give? Cosine 2x divided by sine 2x will give us cotangent. So here we are going to have minus 4 times 1 divided by sine 2x times cosine 2x divided by sine 2x. Wow. And this will give us minus 4. 1 divided by sine 2x is the same as cosec 2x. And cosine 2x divided by sine 2x will give us cotangent 2x as our final answer. Wow, 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 wow. That is if we change it. That is where we will come to. That is where we will come to. Very simple as that. Now, what about if we don't change it and we want to maintain it? Let's see. We want to maintain it. So let's maintain it and differentiate it here. Here we are going to have y equal to secant x cosecant x. U equal to secant x, v equal to cosecant x. If we differentiate du on dx, we are going to get secant x tangent x. If we take dv on dx, we are going to get negative cosecant x cotangent x. So here the derivative of y with respect to x will be given by v cosecant x times secant x tangent x plus u secant x times minus cosecant x cotangent x. And this will give us, we have secant cosecant x secant x. Cosecant x secant x. So we write here secant x cosecant x into bracket tangent of x minus cotangent of x. And this will give us secant x cosecant x into bracket tangent of x is the same as sine x over cosine x minus cotangent is cosine x divided by sine x. Now let's move on. So here this will be the same as secant x cosecant x on the LCM is cosine x sine x, all divided by sine x times sine x will give us sine squared x, cosine x times this will give us minus cosine x. Sorry, cosine squared x. Wow. And here what do? You see that we have a negative sign here. So you can factorize the negative out. Very simple as that. If we factorize the negative out, what will happen? If we factorize the negative out, we are going to have negative secant x cosecant x into bracket cosine squared x minus sine squared x all divided by cosine x sine x. Wow. And what does the top expression represent? That is what we've done here. Cosine squared minus sine squared. And we did it in the last example. So cosine square x minus secant minus sine square x is equal to cosine 2x. So here we are having minus secant x cosecant x on cosine 2x divided by cosine x sine x will give us what? Cosine x sine x is what we've done here. It will give us this one, half of 2 sine x. So here we are going to put here, you see mathematics, half of sine 2x. Wow, I love mathematics. Now let us proceed. Let me clear the top. I want the final answer to be there so that we see that the answers are the same. So here, what are we going to do? This one is the same as minus secant x cosecant x, and then this will become cosine 2x divided by, okay, let me do it here, times 2 on sine 2x, because this is the same as sine 2x divided by 2, so if it is multiplied, it will turn upside down. So this will be the same as negative secant x cosecant x, and what will happen? This will become 2 cos 2x divided by sine 2x. And you see that we have this one here, the cotangent. We have the cotangent there. We have the cotangent right there in the answer. And here too we have is it this? Okay, let's move on and see. So this will give us minus secant x cosecant x. We are bringing the 2 here, minus 2, and this will become cotangent 2x. Now how do we simplify this to get cosecant 2x? Let's see. Now, we want cosecant. So here, this is the same as minus 2. Secant x is the same as 1 divided by cosine x dot 1 divided by, this one also is sine x, cotangent 2x. And this is the same as minus 2, 1 divided by cosine x sine x times cotangent 2x. Wow, I love doing mathematics. Now, this one, I've cleaned it. It's here. This one is the same as sine 2x. Yes, we did it. The same as sine 2x. So here you have negative 2, 1 divided by, sorry, it's the same as half of half. Okay, let's do it. If we have sine x plus x is the same as sine x cosine x plus cosine x sine x. So here sine 2x will be 2 sine x cosine x. So sine 2x divided by 2 is the same as sine x cosine x. So this is the same as sine 2x divided by 2 times cotangent 2x. I want to give you more trigonometric identities in solving this problem. Now, this will become what? This will become negative 2 times 2 divided by sine 2x cotangent 2x. Wow. We are getting there. Almost. So here, this is the same as negative 4, that is this times this, dot 1 divided by sine 2x dot cotangent 2x. And we have minus 4. Wow. Cosecant 2x cotangent 2x, as we have had before. I hope you've loved going through this trigonometric identities, and that is said or destined for you. Now let us move on to the last example. So since these are identities, you could have also ended up where? You could have also ended up at some place without going through the simplification. Let me see this here. We are having this, we have this one. So when we had this one, okay, you could have also ended up here. Let's do that one. Minus secant x cosecant x. Then this one, the top there is what do we call it? Cosine square minus sine square gives us cosine 2x divided by this one. We have dot 2 on sine 2x. So we take negative 2 out, secant x cosecant x cotangent 2x. Yes, you could have also ended up here. If you can't go further, don't worry yourself going further. Just drop it here and go your way. Yes, but since it is an identity, we can get the answer using the trigonometric identities. That is why I proved to where we had the first example. Now, let's take this one. If we have y equal to secant x sine x, what do we do? Wow. Here we take y to be equal to, secant is the same as 1 divided by cosine x dot sine x. So you have y equal to sine x divided by cosine x. Wow. And you can use the quotient rule. Let's do that. We take u equal to sine x. We take v equal to cosine x. We take the derivative of u with respect to x equal to cosine x. The derivative of v with respect to x equal to negative sine x. The derivative of u with respect to x equal to cosine x. The derivative of v with respect to x equal to negative sine x. So from the quotient rule, the derivative of y with respect to u will be v du on dx minus u dv on dx divided by v squared. And that is the same as v is cosine x. Du dx is the same cosine x. minus what is u? U is sine s, and the x is also minus sine x, all divided by cosine x squared. So this will give us cosine squared x plus sine squared x, all divided by cosine squared x. And that, I said that if you have not watched my video on trigonometric identities, watch that video. Cosine squared x plus sine squared x will give us 1 divided by cosine squared x, and that will give us what? Secant squared x. Wow. Alternatively, we could have also solved this using the product rule. So let's go through that. As I said, I want to review the secrets, the tricks in differentiating trigonometric functions. Now, let's leave the answer there and take y equal to secant x sine x. Wow. So here we take u to be equal to, we take u to be equal to secant x and v equal to sine x. The derivative of u with respect to x equal to secant x tangent x. The derivative of v with respect to x is equal to cosine x. Now from the product rule, we are going to write dy on x equal to v, that is sine x secant x tangent x, secant x cosine x. Now what do we do? We have secant x here, and we have another secant x here. Wow. So we are going to write this to be equal to secant x times sine x dot tan x is the same as sine x divided by cosine x, plus here it will make cosine x. Now this is the same as secant x times sine x will give us sine squared x divided by cosine x. Wow. Plus cosine x. Now we multiply here by the LCM. So this is the same as secant x times sine squared x plus cosine squared x, all divided by cosine x. And what do we get here? This is the same as secant x times 1 over cosine x, because sine squared x plus cosine squared x is 1. So this is where we reach. Now this will give me secant x dot 1 over cosine is the same as also secant x, and we left with secant squared x as our final answer. So this is part 1. Just wait for part 2. Please leave your comments, leave your difficult questions under the comment sections too, and then kindly support my channel. If you have not also subscribed, kindly subscribe to my channel for more videos. Thank you for watching. Bye bye.